So in this video, we're going to be dealing with the fact that the limit as x approaches to positive or negative infinity of sine x over x is going to be equal to 0. This is very important. This is also going to be very useful when evaluating limits and that go to infinity, so infinite limits, and or negative infinity, so but still infinite limits for in this form or in a form that's very similar to this. So this is going to be extremely useful, but there's some places that you cannot use this, and some places that you can and that you should be aware of using. So let me show you some examples. So let's say that we had the limit as x approaches to infinity of 5 times sine x over x. So in the last video, we talked about like the limit as x approaches 0, and we talked about the same form and how that's equal to 1. And whenever we had a scenario like this, what we did was we took this 5 and we moved it out, right? Here we can do the same if we wanted to. Actually, let me do that for the first example. This is just going to be 5 times the limit as x approaches to infinity of sine x over x. So still this, but then we know that this thing is equal to 0, so this thing is 0. So this is just going to be equal to what? 5 times 0? That's 0. So regardless of any constant that we multiply, it's still going to be equal to 0. So we don't even have to do this, but if you get confused and you want to do it, that's completely fine as well. So that's the interesting thing about this. Whenever we have zeros involved, our calculations get a lot easier. So that's one thing you should notice. So let me say one more thing about this. So another thing that we wanted to discuss, or we discussed last time, was the fact that the limit as x approaches to 0, but in this case we have positive or negative infinity of sine of x over x, right? This is equal to 0. But last time we discussed how when this was 0 and we have 1, x, this thing inside here, can be u of x. And the thing with u of x is that it has to be a function that has x terms within each of the terms needs to have x in them. So like, for example, x squared plus x, right? This would be valid. But if we had like x squared plus 2, this would not be valid, right? This would not be valid for the property there. So, but in this case, when we have like infinity, u of x can be anything. It doesn't have to be something, a function where each of the terms have x in it. It can be something like x squared plus 2 or x cubed plus 4x plus 5. This also works. This works completely okay as well. So you don't necessarily need to have x in each term, which is another kind of thing that you have to know. So if we had something like the limit as x approaches to negative infinity of sine of 2x by 2x, of course this is equal to 0. But if we also had something like the limit as x approaches to infinity of sine of x squared plus 4 divided by x squared plus 4, this would also be equal to 0. Now the examples that I'm going to be showing you in this video, like this, these are quite easy examples, right? If you know this property really well, they shouldn't be too challenging. However, on exams and other sorts of homework problems, they can be kind of tricky because you have to do a lot of manipulation. But these videos are mainly for understanding the rules, helping you to understand the rules. So let me point out one more thing about this. If you had the limit as x approaches positive or negative infinity of x by sine x, we cannot use the same property here. We cannot use the same property. We can't justify this like we justify this. So before, I know in the last video we talked about how limit as x approaches 0 of sine x over x or x over sine x is still equal to 1. Here we cannot do that. We can't use that fact. Okay, so yeah, these are the facts that we were talking about. The fact that the limit as x approaches to 0 for sine x over x or x over sine x is equal to 1. And remember, the functions that are inside the sine they have to be, in that case, something that has a function that has x's in each term. But in this case, when you have the limit as x approaches positive or negative infinity of sine x over x, the x, which is equal to 0, the x can be any function u of x, which can be anything, and it would still be equal to 0. And remember that this does not work for x over sine x. That's not going to be applicable for this problem, these kinds of problems. And always remember, whenever we have zeros like this, our calculations are always going to be easier because zeros can cancel things out. But if you want to always show your work and do all the steps, that's also completely okay. I hope you found these videos helpful.